today's video, we are going to dive into an advanced VXLAN multi-site development using EVPN and BGP. If you are working with data center network and looking to extend the VXLAN across multiple locations, this is the guide for you. Okay, this lab will focus on the VXLAN. VXLAN stands for Virtual Extensible LAN multi-site deployment. So which is the critical technology for interconnecting data centers. We're maintaining an L2 extension with scalability and efficiency. So we are using EVPN, okay, as a control plane for the VXLAN to handle the layer 2 and layer 3. This forwarding across the multiple different data center where we're going to ensure optimal routing and redundancy. So the topology is here. We have the two data center. It is the DC1 and the DC2. DC1 has AS number, which is 100 of my part 1. AS 110 is my part 2. DC2 AS number instead is AS200. The BGP control plane handles advertising the MAC and an IP address reachability between the data centers. So each DC will have their own internal BGP AS number. The interconnectivity between the DC will be achieved by my super spine router. This is going to be my ISN, intersite network. Intersite network is AS number 777. Is my super spine router. They're implemented on the leaf switches, which are responsible for encapsulating the L2 frames into, the VXLAN header. The next thing we have is the border leaf. The border leaf is typically a leaf node, goes to the outside and sends routes inside. And border gateways, these are called a BGW. Okay, BGW. They're also going to be my spine. It can be leaf also. They have DC1 spine 1, DC2 spine 1. They are the border gateways. The border gateways provide connectivity between the VXLAN fabric domains across multiple data centers. So DC1 is a fabric, DC2 also a fabric. We use border gateway to interconnect different VXLAN fabric domains. So instead, we're relying on the flood and learn, which is inefficient in the large scale network. The EVPN will distribute MAC and IP address information across data center. And each VTAP we talk about is the leaf will advertise the host reachability information via a, the type 2, and we'll have a type 3 BGP EVPN routes. The BGW here we're talking about is 1.1.1, 4.4.4 will serve as an interconnect point between the VXLAN fabric of both data centers. So these BGW use the MP BGP, which is the, the type 5 routes to exchange the L3 reachability information. And we have the is IR, which stands for ingress replication, or we could use the multicast, will handle bomb traffic, the bomb traffic, which stands for broadcast, unknown unicast, and multicast traffic within the fabric. In each DC, DC1, DC2 has a unique AS BGP AS 100, 200, allowing the user of the AS path pending of BGP community for the traffic engineering. The routes goes out will always pend 100. Here, 200. This ensures the efficient inter-DC communication while we're preventing the loops. Each device in the DC1, like the host, will communicate with the device in the DC2 over the VXLAN tunnel. So the leaf switch will encap, encap slate layer 2 traffic into the VXLAN packets and send them over the fabric, IP fabric. So in totally, we walk through the logic data stack and the components, the leaf spine, BGW, super spines, etc. And we are going to show you how VXLAN VTAP configures on the leaf switch. I will configure the VLAN to VNI. Mapping. So we'll explain you how type 2 and type 5 routes are exchanged between the data center, and we'll configure the BGP peering for that. I will verify you how the BX10 tunnel between the DC1 and the 2, and we'll show you some commands like show BGP EVPN, show VXLAN. I will test the connectivity between the tenants across DC. We're going to ping and trace routes and between the device in different DC. I will track the ARP table and MAC address learning. Okay, so that's the time we get on it. Now the data center we'll work on is the DC2. The first, let's log on to my DC2 spine 1. What we'll enable is the feature OSPF. Feature, we'll have to enable the ping. There's a RP address, IP ping RP address. We'll make like 200.1.1.1.1. Enable the router OSPF. Give a router ID. That's 444.4. Interface loopback 0. We say it's my loopback 4.4.4. IP router OSPF1 area 0. IP ping sparse mode. So run interface loopback 0. Next, we'll use loopback 1 with describer as RP address. loopback 0 is gonna be my VTAP address. So we're putting my loopback address. So run interface loopback 1. Here you go. We're taking care of my Ethernet 1 and 1 to super spine, and the E/2, that's to my leaf 1, and E/3 that goes to my border leaf. Interface E11, no shut, no switch port, IP 47.1.1. We don't use OSPF because, it's not OSPF to my super spine. Interface E12, no switch port, IP router, OSPF1, area 0, IP ping sparse mode, no shut. Interface E13, no switch port. That's my IP address. Let's double check. The next feature we'll enable is a feature BGP and MV overlay EVPN. That's all we're good to go to enable our BGP 200 neighbor. That's my leaf 1, DC2 leaf 1, remote 200. Add an address family layer to VPN EVPN. We're gonna send community extended. It's gonna be our RR. Next neighbor is gonna be my border leaf. Sing AS. Show run BGP. All right, that's my, my spine. Save the config. C2 leaf 1. We're gonna to configure this as a leaf node. There are a couple of features we need to enable. First one, OSPF. Ping. Feature fabric forwarding. Feature into VLAN. Fabric forward. We need an adding cast MAC address change. Give a pin. RP is my spine. Router OSPF 1. Router ID. Interface 1 minus loopback 0. IP router with SPF 1, area 0, IP ping sparse. Interface you want 1, that goes to my spine. IP address, we're dealing with underlane right now. IP router OS PF1 area 0, IP ping sparse mode, no shut. Next thing is we enable NV overlay EVPN feature BGP feature VN segment based feature NV overlay. Okay, all the things we have to enable for the new features. Then the B router BGP 200. There's only one neighbor that goes to my spine. Okay, IBGP same AS. Address family, loopback, update source, EVPN. We want to send community, extended. Now we're dealing with the mapping, right? The mapping thing we have to do is, the VLAN 100. We're gonna give a name as it's gonna be L2, VNI 1, VN segment 100, VLAN 110, name L2 VNI 2, VN segment 10110, VLAN 111. Okay, name is L3 VNI VN 11111. Next, for tenant 2, we have L2 VNI also, that's VLAN 200, named L2 VNI 12 in tenant 2. So VN segment 10200. Next VLAN 210, name is going to be L2 VNI 2-2. VN segment 10210. VLAN 222, that's L3 VLAN, VNI, L3 VNI, VN segment 22222. Okay, so run VLAN. Here you go. Show VXLAN. It'll take out a while to show you all that. At this time, we'll show VN. That's gonna be show NVE VNI. See if it doesn't show you, but okay, I'll configure the others. For next, we want to define a VIF content. Tenant 1, VNI 11111, RD auto, right? Address, family, IPv4, unicast. We wanted to route target, both auto, route target, both EVPN. Both auto EVPN. Okay. Then we're going to enter VLAN 100, no shutdown. VIF member, we wanted member is tenant 1, IP address 192.168.1.254/24. Fabric forwarding mode and cast gateway. Interface VLAN 110, no shut. VIF member. Same thing, this is tenant 1, IP address 11254/24, fabric, forwarding, mode, and encast gateway. Okay, next interface, VLAN 111 is a L3 VRF member tenant 1. No IP redirect, and this IP forward. Say my L3 BNI. Now show run interface VLAN 100 111 110 111. That's all I was thinking about a tenant 1 VLAN interface. As next, we're gonna take care of the tenant 2 VRF content tenant 2 BNI 222.22 RD auto address family IPv4 unicast route target both auto route target both auto EVPN show run BF tenant 1 tenant 2. We're missing some the interface VLAN 200 no shut VF member that's tenant 2 IP address 192.168.2.254/24 fabric forwarding mode and cast gateway interface VLAN 210 no shut VF member tenant is 2 IP address fabric forwarding mode and cast gateway interface VLAN 222 no shut VF member tenants 2 no IP redirect IP forward show run VF tenant 2. Then that's everything. Here you go. Show run interface VLAN 200 220 210 222. Here you go. Lastly, we take care of the interface MVE1. That's no shut. Host reachability protocol BGP. Source interface loopback 0. Member VNI 10100. Let's suppress the ARP MCAST 225.1. Member VNI again 10110 L2 VNI MCAST 225.1.1. Suppress ARP member internet 2 VNI 10200 suppress ARP MCAST 225.1.1 say .2. Let's go back to the member VNI 10110. Being started using 1, we'll use 11. Okay, I will show you everything, don't worry. The member, we're going to take care of 10210 MCAS 225.1.1.21. We're taking care of. Lastly is the member VNI 111.1.1. associated VF member VLAN 1.2.2.2.2 associated VF. It may seem a lot config. Show run interface MVE1. We're going to examine it. Let's see what I'm missing. I think I'm missing some of the config, like 10100. That's correct. That's not right. So we're going to enter MV1. We're going to say this. That's correct. Member VNI 10110. Hit that one. Member VNI 10200. Mcast. Say .2. Member VNI 10210. Mcast. Show run interface MVE1. Here you go. All right, I promised the last is to take care of EVPN VNI 110.100. Yeah, it's L2. So RD, we want to use auto. Route target, both auto. Next VNI 10110 L2. RD auto. Route target, both auto. VNI 10200. That's also L2. RD auto. Route target, both auto. VNI 10210 is R2. RD auto. Route target, both auto. Show run BGP. At the end, you will see the config. They are here. Show MVE VNI. Take care everything well configured. MCAS group, VNI, L2 VNI, L3 VNI. They were very clearly configured. Save config. So next thing we're going to take care of the DC1. The DC1 will have spine 1, leaf 1, and my leaf 2 will have all going to add like the 10 and 2, 10 and 2 VNIs, VNIs 10 and 2. Okay, so let's take a look. First one, my spine 1. Spine 1 doesn't have a lot thing. It needs to configure E11, which goes to my super spine route server IP address. Shut. Show run. Save that. Right. Just wait a second. I still have the DC2 board leaf to configure for the same thing on my DC2 leaf 1. So now to DC2 border leaf, feature OSPF, feature ping, feature fabric, forwarding, feature interface VLAN, fabric forwarding, and encast MAC IP ping. Same thing, RP address will gonna be my spine. Few features, we have to enable EVPN, feature BGP, features VN segment based, feature MV overlay. Now we take care of the router BGP 200 neighbor for my spine nodes, remote AS200, update source rootback 0, address family L2, EVPN. That's sent community extended. Take a look at VLAN first 100, name L2 VNI, VN segment 10100, VLAN 110, name L2 VNI 2, VN segment, VLAN 111, name L3 VNI, VN segment 111, VLAN 200, name L2 VNI 12, VN segment 10 200, VLAN 210, name is L2 VNI 2-2, VN segment 10210, VLAN 222, name L3 VNI 2, VN segment 22222. Okay. VF content tenant 1 VNI 111 RD auto address family IPv4 unicast route target both auto EVPN also VLAN interface VLAN 100 no shut VF member tenant 1 IP address 168.1.254.24 fabric forwarding mode and cast gateway interface VLAN 110 no shut VF member tenant 1 address fabric forwarding mode and cast gateway. Last in the tenant 1 is VLAN 111 no shut, that's VF member tenant 1 no IP redirect IP forward. Okay, so run VF tenant 1 here we are configured. We need to take off the tenant 2 VF contact tenant 2 instead VNI that's 22222 RD auto address, family IPv4, unicast, route target, both, auto, EVPN also. VLAN, we take care of VLAN 200. So no shut, we have member, no shut, interface, sorry, interface VLAN 200. We have, first no shut, we have member tenant 2 IP address, the interface VLAN 22210, no shut, we have member tenant 2 IP address, the interface VLAN 222, no shut, we have member tenant 2, no IP redirect, IP forward, show, run VF tenant 2. Here you go. We still missing the MVE configure interface. MVE1. We could actually go to my leaf. To run interface MVE1. Can copy and paste in here. Here you go. The last should run BGP. We have EVPN parts of the config. Copy that. Run the paste it here. Should run BGP. We have it. Go to my spine. Show BGP L2 VPN EVPN summary. Go. So now I have seen, I think I have taken care of everything. So I show actually in DC2 spine 1 show BGP L2 VPN EVPN summary. I have my neighbors up. What I have to take care of is to go to my endpoint interface. That's it. I think I just need one. This tenant 3 will take care of later. Let me ping a little bit from server tenant 1, this host, and go show. I can see the 2 prefix. Here you go. The fabric in DC2 is up and running. Let's take a look. DC1 spine. I did take care of it, so that I want to double check it. Isn't just, the running interface E11 to super spines. So in DC1 leaf 1, we want to add is to the tenant 2 VLANs and the VNI mapping. So that's create VLAN 200. Name it. We're gonna name as L2. VNI 1 is tenant 2. 10200. VLAN 210. Next L2 VLAN. VNI. Name is L2 VNI 122. VN segment 10210. VLAN 222. Name L3 VNI 2. VN segment 22222. Okay, taking care of the mapping, we need to go to VRF, create a new VRF called tenant 2 VNI 3 2222 RD auto address family IPv4 unicast route target both auto route target both auto for EVPN also active that interface VLAN 200 no shutdown VF member lattice my tenant 2 IP address fabric forwarding mode any category interface VLAN 200 we're gonna no shut VF member say tenant 2 IP address VLAN 210 no shut next we interface VLAN 222 it's just layer 3 VF interface MVE1 no shut maybe we have the MVE already interface MVE1 yeah here you go I'll just copy and paste the whole MVE config here show run interface MVE1 so run BGP we seems don't have the EVPN config okay alright so let's paste that in so run BGP here okay we have VNI for my tenant 2 also save that config because there's a lot of config for DC1 leave 2 which is here I'm just gonna to copy and paste what I have to do paste all that in and VLAN interface next the MVE and EVPN config here is creating a new fabric is called DC2 is a fabric and serving tenant 1 and tenant 2 and we add a tenant 2 into my DC-WAN also. But anyway, they're separate fabric. Though we have an IP direct connected, we configured to my ISN network. Here is a super spine route switch. This is only the part one we completed for my, for my multi-site setup. The next video will focus on the ISN network and inter-site connections, which is my part two. So stay tuned, guys.